Hello Math 13-14 students. Let's begin lesson 6, linear functions and linear models. But before beginning lesson 6, let's have some review from lesson 4. Some of them will be needed for section 1 and some for sections 2 and 3. This is an optional section. As you can see, this is coming from a section that is de-emphasized in gray. In section 4, we talked about graphs of equations with two variables. Here's an example. We have a relation between x and y. Yeah, now I can use that kind of term. We talked about what it means by a relation in lesson 5. So this equation defines a relation. So it does not define everything from this Cartesian coordinate plane. Just a subset. Typically, a curve or several curves put together. In this particular case, two curves put together. That was an example. And then remember doing the intercept problems. Same example again. And then to find x-intercept, put y equals to 0 and so for x. Turns out it's a quadratic equation, but don't panic. You can easily solve it because this is actually a quadratic type. Factor it with respect to x squared. We went through that already in lesson 4. Finding y-intercepts, put x is 0 and so for y. This time it's a quadratic equation, so it's easier. Okay, those are the kind of background, not directly related to anything actually. Now let's go to, well, still an optional topic, but something directly related to what we are going to do in section 1. Symmetries about coordinate axes. Symmetry by x-axis. Replace y by negative y and simplify. Do we get the same thing or not? That's a problem. Symmetry by y-axis. Replace x by negative x and simplify. Do we get the same thing? And then symmetry by the origin. Substitute x by negative x and y by negative y, both of them, and then simplify. Are they the same? Well, answer to those questions is yes. Then we have the corresponding symmetry. Here's an example. Substitute y by negative y and simplify. Did you get the same thing? Indeed, yes. Not coincidentally, if you have something here, part of this curve here, and take the negative of that, y coordinate flipped over here, and yes, we do have a curve. Same here, y coordinate here, flipped over to negative y, yes, we do have a curve. If you do the same thing to the x coordinate, you can test for the symmetry of y-axis. The same curve, this time you can say it is no, because if you substitute x by negative x and simplify, this x has odd powers, so we don't have the same thing. We have negative of here, so no. And look at this graph. Something here, flip the x coordinate to the other side, go to negative x, but there's nothing here. And then find something here, negative x, flip over here, but there's nothing there. Kind of like that. There's no symmetry about y-axis. And then here's an example of symmetry by the origin. Substitute x by negative x and y by negative y and simplify. Both have even powers, so negative all disappear. So whether I use substituting x or substituting by y or both of them, they're all symmetries. So not coincidentally here, we have all symmetries. Symmetry by the x-axis, symmetry by the y-axis, origin, all three as a matter of fact. Now let's work on those in particular to graphs of functions. And these are going to be more directly related to section 1 topic. Test this. We have a graph of a function. Now in lesson 4 we considered as just an equation and just a curve, but now everybody can see that this is a function and graph of a function, so it passes the vertical line test. So there's no way I'm going to get a symmetry by the x-axis. But symmetry by the y-axis, that's the question here, and yes, you can check. Graph confirms that too. Substitute x by negative x and simplify. Do we get the same thing? The answer is yes, and look at the graph. Next example, this time, well, do it on your own, what do you have? Or maybe you will already remember it from lesson 4. We have symmetry about the origin. Substitute both x and y by negative x and negative y, and then simplify, we get the same thing. And as you can see, yes, we have the desired symmetry. And then this one is not a graph of a function, but it satisfies all symmetries. If I make one more comment, these two examples, this one, symmetric about the y-axis, those kind of functions are called even function. And this one here, symmetric about the origin, those kind of functions are called odd functions. We can define like this if you're interested in precise definition and proofs, but most students probably will not be interested, so I'll just mention and move on. If you're majoring in mathematics or math education, please let me know. I'll mentor you a little bit about proof writing. It's algebra level. Otherwise, let's just move on. Overwhelming majority of the students are not doing that. So in this case, we end up with, as you can see, symmetry about the y-axis. Substitute x by negative x, get the same thing, basically. Here, substitute x by negative x, not only that, y by negative y, and that's how this negative is coming into play, and I'm not going to prove that. It's not too difficult, but most students are not interested in it. In any case, if you have this, we have an odd function, that is a function, graph of a function. We have a function whose graph is symmetric about the origin. There you go. A function whose graph is symmetric about the y-axis. A function whose graph is symmetric about the origin. Those are even function and odd functions. And some algebraic properties. No, I don't think these are worthy of class time unless you are majoring in mathematics and if you want proofs. And we're going to come back and talk about this when we discuss section 1, when we discuss some power functions, even power versus odd power. That's about it. Now we have some diagonal symmetries, but even in lesson 4 we kind of skipped, right? Because it's not that important. Switch x and y, then we have diagonal symmetry and the principal diagonal, this diagonal here. And that bears some importance in lesson 11, maybe 12. We're going to talk about that when it appears. And this one is just for an argument's sake, not important at all. Okay, so much for symmetries. Now let's go to lines. And these are going to be related to sections 2 and 3. Slope concept is important in lines. Rise over run, the difference of y coordinate over the difference of the x coordinate. And then we have the general form of the line, slope intercept form of the line, and then slope point forms of the line. Flip this y0 to the other side, vice versa. They are the same, so this one and that one, those are equivalent. 2-point form of the line, again these two are equivalent. And horizontal and vertical lines, horizontal lines y equals to b, that's a graph of a function. Vertical line x equals to a, that is not a graph of a function. Here, this graph passes the vertical line test. Draw a bunch of vertical lines, then this graph passes each vertical line only once. This itself is a vertical line, so many x coordinate many y coordinate values here, actually infinitely many y coordinate values, share the same x values. So this is not a graph of a function. So x equals to a, No, that's a line, but it's not a graph of a function. Y equals to b, no x. It is a graph of a function, just a constant function. Okay, lines reviewed in terms of in the viewpoint of functions. And finally, parallel lines and perpendicular lines, same slope than parallel, and negative reciprocal than perpendicular. Same lines bear some importance in functions, basically. They share the same rate of change or derivative. Well, I'm using calculus term. As for perpendicular, that's not going to show up until we go all the way up to multivariable calculus or calculus 3. So in intermediate algebra, that was important, but not important anymore. Okay, so much for reviews in lesson 4. We reviewed in general some preparation and then some symmetries, even function, odd function, symmetries about y-axis and symmetries about the origin, those kind of things in preparation for section 1, and all kind of properties about lines in preparation for sections 2 and section 3. Okay, that concludes section 0, the optional section, and let's meet again from section 1, which is required. Sections 2 and 3, those two are required as well.